explain what is the multiplexer. So it's somehow clear from its name, should be actually the opposite of the multiplexer, right? So that means if I consider the multiplexer as a module or the unit or whatever you call, so definitely same with the multiplex, it has an address. So the address bar is n bit. Okay. So we start with actually n equal 2. So we consider we have a1, a0. Okay. So if this is the, let I write the mux. So you guess how many input we should have and how many outputs. In multiplexer, whenever you have n, you have 2 power n input and 1 output. In Demux, it's the reverse of that. That means you just have 1 input all the time. So this is just 1. And the output is 2 power n. So for our case, so this is should be 2 power n. So for our case, we actually have 2, n is 2, so 2 power 2 will be 2. So that means you could label these 0, 1, 2, and 3. Okay. So let us just check the chat. Yeah, if you have any question, you could actually type on our chat box. So you could actually guess how actually should be actually work, right? So see, I have n bit address, so similar with the previous one, I could say these 2 bit, you have 2 bits, you could actually have 2 power 2 or 4 different bit pattern here and the address. So whenever that is 0, 0, it's connect these 1 input output 0. So whenever this is 1, it's connect these to the 1. Whenever that's 2, it's connect this to the 2. Whenever that is 3, it's connect this to the 3. Okay. Exactly is the opposite of the multiplex. So maybe that's better to write here. This is the Demux, and it is 1 by 4 Demux, right? 1 input and 4 output. So if I increase n, you tell me which different type of the demultiplexer I could make. So what should be the next? If I give n 2, so I should have what? N is 2, we have 1, 2, 4. So if n is 3, definitely all of them should be 1, right? So the demultiplexer should have 1 input, right? So that is 1 by. If n is 3, 2 power 3 should be 8. You could have 1 by 8. You could have, what should be the next? 1 by, if n is 4, what should be, multiplexer should be 1 by 16, definitely. So that means you have 1 input, 16 actually output. So if you have n is actually 5, should be 32, and again you could actually increase these address, and 2 power n all the time will be the output, and all the time the 1 is number, you have just 1 input for your demultiplexer. So how you could make that? So for making these unit base of the basic gates that you have, this is actually the inside the box. So you just have 4 AND gates. So these are the AND gates. So, and each of them is your output. Okay, so this is these 4 output that you have. So I give the 0, 1, 2, 3, just number of the output. So definitely all of them, one connection to one input for all these four and one output definitely is your input. If I label this as a X, so one connection is X, no doubt about that. You connect X to all of them. So let's see how we could actually connect A1 and A0. Okay, so if you consider these as your A, and it's not, again, have something like this. This is A1. Do the same thing for A0, 1, and it's not. Okay. So now let's see where we should have the connection. So the connection is, see, when these X connected to the 0, whenever the both of these A0 and A1 is a 0, okay? So that means the connection for the first one should be A1 prime and A0 prime, okay? So when these input connected to the 1, whenever you have A0 is 1, A1 is 0. So this is 1, so that means you should have one connection of the A0, and this should be 0, that means should be A1 prime, okay? So you guess, how about 2? For 2, for actually these and with 2, number 2, where I should have the connection, you tell me, on A0, A0 prime, A1, or A1 prime. Guess. Just type in the chat box where we should have the connection. Yeah, A0 and A1. Just be careful. So see, what is the 2? 2 is 1, 0, right? So that means A1 should be connected, but these A0 should be prime, okay? That is how you could remember that. So how about 3? If you want to know what is the connection, you need to say when we connect these X to these output 3, whenever this is 1 and 1, right? So that means here you have A0, A1, and here A0, okay? So similar with the decoder, encoder, multiplexer, we actually have enable pin. So I add one enable pin here. I call this enable. Usually you put one bar, which is means these dot that you see. It tells these actually this pins active with the 0. That's the meaning. That's the reason why I put these bar on the enable, and also I have this dot here. It says it's active whenever that is 0. So you tell me, whenever these enable is 0, similar with the other enables that we learn, whenever this is 0, the demultiplexer, it's doing its normal job. So whenever this is inactive, which is 1, whenever get 1 is inactive, the all output should be 0. How I could actually have that here, which is that's happened. So you actually have one and not here, and you call these enable. So whenever that is 0, the not is 1, and it should be connect for all of them, right? So see as it works, that's what we expect. Whenever this is 0, which is active, not is 1, and that means this AND has 1, 2, 3, 4 input. One of them is 1. If you have a 1, actually do nothing on the AND, right? Because 1 and everything, it's give the same thing, has no effect on the output, okay? So that means it should be right. So whenever this is 1, the not is 0. That means one of these input of these AND is 0. So that means no matter what you have in the other inputs, the output will be 0. So that means whenever it is not active, the whole output will be 0, no matter what is your input, okay? So this is actually shows what is the demultiplexer is, how you could make the demultiplexer by using the 4 AND gates, and how demultiplexer actually works. So any question about this? So again, when you use this, definitely whenever you have just one input and you have different output and you want to connect these input to the output based off the address that you have. So definitely that should be the place that you need to use that demultiplexer.